I wanted a little tone generator circuit I could use with other projects to trigger if I needed to hear an alert sound at some point, so rather than a simple boring oscillator, I put together this dual 555 circuit that gives a more interesting result. The circuit has two separate oscillators set to run at different frequencies, and the output of the first interacts with the timing circuit of the second, changing the voltage responsible for charging and discharging the capacitor, altering the final output frequency of the second oscillator. While I was making this PCB, I thought I would try another little experiment. I wondered what would happen if I tried to power the tone generator while it was reflowing on the hot plate, if it would kick in and start running when it's soldered, or if something would go wrong. Since I want to try running the circuit while reflowing, I thought it would be best if I had a solder stencil to minimize bridging, and PCBWay sponsored this project. I made sure I had headers for power and audio located on one edge of the board so I could operate the circuit and keep those connections off of the hot surface so they wouldn't melt or short out while the rest of the board is reflowing. I taped the board to the hot plate with Kapton tape so the wires wouldn't move it, connected the output to a speaker, and applied 5 volts. Occasionally I heard a click or pop in the speaker as if power were being applied to the circuit and removed. Eventually the sound came on, but it didn't sound exactly like I was expecting. I wasn't officially measuring current for this project, but I noticed on the 5-volt bench supply, the current was fluctuating between around 250 and 300 milliamps, but I thought it was less than 100 milliamps when it was on the breadboard. At some point, the circuit stopped making sounds and just fizzled out. So I decided to remove power and let it cool down to see if it would recover. I wondered if maybe I exceeded the recommended operating temperature of the 555. It's hard to know without having put a thermocouple directly on the chips because the PCB wasn't sitting firmly on the hot plate despite taping it down. The solid core wires were fighting to tip it back up, so I don't know exactly what temperature the board or the components ever got to. After the board cooled down, I brought it over to the breadboarded prototype version to compare the operation. Now it was sounding more like I originally had designed it to, so it definitely was behaving different on the hot plate under higher operating temperatures. It can be perceived as sounding like a low tone coming on and going off again, or even two different low frequency tones alternating. Switching to the breadboard prototype with the same component values, now I can switch out a few parts to see what happens if I want to change the circuit a little. If I remove R2, it effectively disables the first oscillator, and we just get the uninterrupted second oscillator generating a simple tone, which is the sound I was trying to improve upon for a little tone circuit. Putting R2 back and making a few other changes, if I increase R3 to 100K and lower R4 to 1K, the overall pitch of the tone increases, and the first oscillator now has a subtle modulation effect on the overall pitch, making it sound like the pitch is slightly detuning. On the scope, when triggering on that pulse in the middle of the screen, that reference pulse stays fixed, but the pulses before and after keep appearing in different positions as the pitch changes slightly higher and lower. So having a slightly expanded tone generator circuit like this, instead of a traditional single tone oscillator, can turn a boring beep or tone into something more interesting. Thanks to PCBWay for sponsoring this project. Thanks for watching.